Pythagoreanism originated in the 6th century BCE, based on teachings, or beliefs held by Pythagoras and his followers, the Pythagoreans, who were considerably influenced by mathematics and mysticism. Later revivals of Pythagorean doctrines led to what is now called Neopythagoreanism or Neoplatonism. Pythagorean ideas exercised a marked influence on Aristotle and Plato, and through them, all of Western philosophy. Historians from the Stanford Encyclopedia of Philosophy pointed out Aristotle makes clear that there are several groups of people included under the heading, so-called Pythagoreans, by explicitly distinguishing those Pythagoreans who posited the table of opposites from the main Pythagorean system, which he describes. Two schools. According to tradition, Pythagoreanism developed at some point into two separate schools of thought, the Mathematicoi and the akousmatikoi. John Burnett noted, lastly, we have one admitted instance of a philosophic guild, that of the Pythagoreans, and it will be found that the hypothesis, if it is to be called by that name, of a regular organization of scientific activity will alone explain all the facts. The development of doctrine in the hands of Thales, Anaximander, and Anaximenes, for instance, can only be understood as the elaboration of a single idea in a school with a continuous tradition. According to Iamblichus in the Life of Pythagoras, by Thomas Taylor, there were also two forms of philosophy, for the two genera of those that pursued it, the akousmatici and the Mathematici. The latter are acknowledged to be Pythagoreans by the rest, but the Mathematici do not admit that the akousmatici derived their instructions from Pythagoras but from Hippasus. The philosophy of the akousmatici consisted in auditions unaccompanied with demonstrations and a reasoning process, because it merely ordered a thing to be done in a certain way, and that they should endeavor to preserve such other things as were said by him, as divine dogmas. Memory was the most valued faculty. All these auditions were of three kinds, some signifying what a thing is, others what it especially is, others what ought or ought not to be done. The best of all legislators came from the school of Pythagoras, Cherundus, the Catanian, Zaleucus and Timoratus, as well as many others, who established laws with great benevolence and political science. The whole Pythagorean school produced appropriate songs, which they called exartices or adaptations, synemage or elegance of manners, and apophy or contact, usefully conducting the dispositions of the soul to passions contrary to those which it before possessed. By musical sounds alone, unaccompanied with words, they healed the passions of the soul and certain diseases, enchanting in reality, as they say. It is probable that from hence this name epode, enchantment, came to be generally used. For his disciples, Pythagoras used divinely contrived mixtures of diatonic, chromatic and enharmonic melodies, through which he easily transferred and circularly led the passions of the soul in a contrary direction, when they had recently and in an irrational and secret manner been formed, such as sorrow, rage and pity, absurd emulation and fear, all various desires, angers and appetites, pride, supineness and vehemence. Except from a speech by the character Aristotle, in Protrepticus, thus nothing is more valuable than intelligence, which we say is a capacity of the most authoritative thing in us, to judge one disposition in comparison with another, for the cognitive part, both apart and in combination, is better than all the rest of the soul, and knowledge is its virtue. Therefore its function is none of what are called parts of virtue, for it is better than all of them, and the end produced is always better than the knowledge that produces it. Nor is every virtue of the soul in that way a function, nor is success, for if it is to be productive, different ones will produce different things, as the skill of building produces a house. However, intelligence is a part of virtue and of success, for we say that success either comes from it or is it. History. According to historians like Thomas Gale, Thomas Teller, or Cantor, Archites became the head of the school about a century after the murder of Pythagoras. According to August Bock, who cites Nicomachus, Philolaus was the successor of Pythagoras. And according to Cicero, Philolaus was teacher of Archites of Tarentum. According to the historians from the Stanford Encyclopedia of Philosophy, Philolaus and Eurythus are identified by Aristoxenus as teachers of the last generation of Pythagoreans. Heresiocrates is mentioned by Aristoxenus as a student of Philolaus and Eurythus. The Mathematicoi were supposed to have extended and developed the more mathematical and scientific work begun by Pythagoras. The Mathematicoi did think that the akousmatikoi were Pythagorean, but felt that their own group was more representative of Pythagoras. Except from a speech by the character Aristotle in Protrepticus, many of the more recent Pythagoreans assumed that mathematics has as its subject matter only the things that are the same and in the same way, and hypothesized only these principles. So in the same way they define as different both the sciences and the demonstrations about such things. But since both in the speeches preceding this point and in the later remarks we will demonstrate that there are many and different substances that are unchangeable and exist in the same state, not only the ones in mathematics, and that those are more senior and more honorable than these. And we will also demonstrate that these mathematical principles are not the only ones, but there are also others, and these in fact are more senior and more powerful than those. And that these are not the principles of all the things that exist, but only of some. So it is for these reasons that the mathematical demonstration now demands a determination of which of the qualities it can demonstrate remain the same and in the same way, and from what kinds of principles it reasons, and about what kinds of problems it produces the demonstrations. Numbers commentary from Sir William Smith, Dictionary of Greek and Roman Biography and Mythology. Pythagoras resembled greatly the philosophers of what is termed the Ionic school, who undertook to solve by means of a single primordial principle the vague problem of the origin and constitution of the universe as a whole. But, like Anaximander, he abandoned the physical hypotheses of Thales and Anaximenes, and passed from the province of physics to that of metaphysics. And his predilection for mathematical studies led him to trace the origin of all things to number, this theory being suggested, or at all events confirmed, by the observation of various numerical relations, or analogies to them, in the phenomena of the universe. Since of all things numbers are by nature the first, in numbers they thought they perceived many analogies to things that exist and are produced, more than in fire, and earth, and vapor, as that a certain affection of numbers was justice, a certain other affection, soul and intellect, another, opportunity, and of the rest, so to say, each in like manner, and moreover, seeing the affections and ratios of what pertains to harmony to consist in numbers, since other things seemed in their entire nature to be formed in the likeness of numbers, and in all nature numbers are the first. They supposed the elements of numbers to be the elements of all things. Brandis, who traces in the notices that remain more than one system, developed by different Pythagoreans, according as they recognized in numbers the inherent basis of things, or only the patterns of them, considers that all started from the common conviction that it was in numbers and their relations that they were to find the absolutely certain principles of knowledge, and of the objects of it, and accordingly regarded the principles of numbers as the absolute principles of things, keeping true to the common maxim of the ancient philosophy, that like takes cognizance of like. Aristotle states the fundamental maxim of the Pythagoreans in various forms. According to Philolaus, number is the dominant and self-produced bond of the eternal continuance of things, but number has two forms, the even and the odd, and a third, resulting from the mixture of the two, the even-odd. This third species is one itself, for it is both even and odd. One, or unity, is the essence of number, or absolute number, and so comprises these two opposite species. As absolute number it is the origin of all numbers, and so of all things. This original unity they also termed God. These propositions, however, would, taken alone, give but a very partial idea of the Pythagorean system. A most important part is played in it by the ideas of limit, and the unlimited. They are, in fact, the fundamental ideas of the whole. One of the first declarations in the work of Philolaus was that all things in the universe result from a combination of the unlimited and the limiting, for if all things had been unlimited, nothing could have been the object of cognizance. From the unlimited were deduced immediately time, space, and motion. Then again, in some extraordinary manner they connected the ideas of odd and even with the contrasted notions of the limited and the unlimited, the odd being limited, the even unlimited. The akousmatikoi based on a single account by Iamblichus. The akousmatikoi focused on the more religious and ritualistic aspects, based on instructions from Hippasus. Ceremonies. According to Sir William Smith, the Orphic worshippers of Bacchus did not indulge in unrestrained pleasure and frantic enthusiasm, but rather aimed at an ascetic purity of life and manners. The followers of Orpheus, when they had tasted the mystic sacrificial feast of raw flesh torn from the ox of Dionysus, partook of no other animal food. They wore white linen garments, like Oriental and Egyptian priests, from whom, as Herodotus remarks, much may have been borrowed in the ritual of the Orphic worship. Herodotus not only speaks of these rites as being Egyptian, but also Pythagorean in their character. The explanation of this is that the Pythagorean societies, after their expulsion from Magna Graecia, united themselves with the Orphic societies of the mother country, and of course greatly influenced their character. But before this time the Orphic system had been reduced to a definite form by Pherecydes and Onomacritus, who stand at the head of a series of writers, in whose works the Orphic theology was embodied, such as Cercops, Brontinus, Orpheus of Camarina, Orpheus of Croton, Arinote, Pacinus of Miletus, Timocles of Syracuse, and Zopyrus of Heraclea or Tarentum. Besides these associations there were also an obscure set of mystagogues derived from them, called Orphiotelists, who used to come before the doors of the rich, and promised to release them from their own sins and those of their forefathers, by sacrifices and expiatory songs, and they produced at this ceremony a heap of books of Orpheus and Musaeus, upon which they founded their promises. The nature of the Orphic theology, and the points of difference between it and that of Homer and Hesiod, are fully discussed by Müller and Mr. Grote, but most fully by Lobeck, in his A Laupamuse. The book The Works of Aristotle mentioned Aristotle says the poet Orpheus never existed. The Pythagoreans ascribe this Orphic poem to a certain Circon philosophy. According to Charles Peter Mason in Sir William Smith Dictionary of Greek and Roman Biography and Mythology, it appears, in fact, from this, as well as from the extant fragments, that the first book of the work contained a general account of the origin and arrangement of the universe. The second book appears to have been an exposition of the nature of numbers, which in the Pythagorean theory are the essence and source of all things. Except from a speech by the character Aristotle, in the book Protrepticus. The Pythagoreans honored the effort put into mathematics, and coordinated it with the observation of the cosmos in various ways, for example, by including number in their reasoning from the revolutions and their difference between them, by theorizing what is possible and impossible in the organization of the cosmos from what is mathematically possible and impossible, by conceiving the heavenly cycles according to commensurate numbers with a cause, and by determining measures of the heaven according to certain mathematical ratios, as well as putting together the natural science which is predictive on the basis of mathematics, and putting the mathematical objects before the other observable objects in the cosmos, as their principles. Pythagorean thought was dominated by mathematics. In the area of cosmology there is less agreement about what Pythagoras himself actually taught. The Pythagorean conception of substance, on the other hand, is of unknown origin, partly because various accounts of his teachings are conflicting. The Pythagorean account actually begins with Anaximander's teaching that the ultimate substance of things is the boundless, or what Anaximander called the apeion. The Pythagorean account holds that it is only through the notion of the limit that the boundless takes form. Pythagoras wrote nothing down, and relying on the writings of Parmenides, Empedocles, Philolaus and Plato results in a very diverse picture in which it is difficult to ascertain what the common unifying Pythagorean themes were. Relying on Philolaus, whom most scholars agree is highly representative of the Pythagorean school, one has a very intricate picture. Aristotle explains how the Pythagoreans developed Anaximander's ideas about the apeion and the pyrrhon, the unlimited and limited, by writing that for they, the Pythagoreans, plainly say that whether one had been constructed, whether out of planes or of surface or of seed or of elements which they cannot express, immediately the nearest part of the unlimited began to be drawn in and limited by the limit. Continuing with the Pythagoreans, the Pythagoreans, too, held that void exists, and that it enters the heaven from the unlimited breath. It, so to speak, breathes in void. The void distinguishes the natures of things, since it is the thing that separates and distinguishes the successive terms in a series. This happens in the first case of numbers, for the void distinguishes their nature. When the apeion is inhaled by the pyrrhon it causes separation, which also apparently means that it separates and distinguishes the successive terms in a series. Instead of an undifferentiated whole we have a living whole of interconnected parts separated by void between them. This inhalation of the apeion is also what makes the world mathematical, not just possible to describe using maths, but truly mathematical, since it shows numbers and reality to be upheld by the same principle. Both the continuum of numbers and the field of reality, the cosmos, both are a play of emptiness and form, apeion and pyrrhon. What really sets this apart from Anaximander's original ideas is that this play of apeion and pyrrhon must take place according to harmonia.